Hi everyone, let's do today's daily LeetCode challenge question, which is combination sum 2, and I'm not sure if I can do this or not. Oh wow, looks like I've already done this. No, I've not done this before. Okay, I will just do 20 minutes, okay? 21 minutes, and if I cannot do it in within 21 minutes, then I'll just look at the solution. Given a collection of candidate numbers, candidates, and target number target, find all unique combinations in candidates with the candidate numbers summed with the target. So there are the list of these candidate numbers and the target, so I need to find all the unique combinations. So suppose 11612512726, and okay, so how can I do this question? So the question, it is simple, it's not hard to understand. Each number in candidates may only be used once in the combination. The solution set must not contain duplicate candidates, and candidates length can go from 1 to 100, and candidates I can go from 1 to 50. Okay, so the number will not be greater than 50, and the target will be from 1 to 30. Okay, so how can I get this all unique combinations? So suppose this is the example, then 10 1 2 1 2, so I need to find the sum, right? Okay, so sum is 8. So how can I find this? Let's see. Let me think of a brute force solution first. So 10 1 2 7 6 1 5. And find all your unique combinations. It's been a long time since I have not done LeetCode, like 2 3 4 5 months, so I have forgotten all the patterns for combination sum and whatnot. So I am thinking from scratch. Okay, I do not know, I do not have any memory or anything in my mind. So how will I do this from trace? I need to find the combination sum. So 10 1, so 10 cannot be 1 can be a candidate. So from 1, what can be the other? 1 can be 2, right? And another one can be 7. And each number in candidates may only be, so what if, so it's 1 7 and 7 1 same or not? I think it is same, right? Because I need to find a unique combination. So okay, so 1 2 and 1 7, it is already 8. So 1 2 and then 1 to 6 7 8 9. So 6 cannot be there. 1, okay, 1 can be there, and then 5. So 1 2 1 5 5 6 7 8. So this is also not possible. Okay, so this is what happens when I want to include 1. And what if I start from 2? 2 7 2 6 7 8 2 3, and yeah, like this. 2 1 and then 5, right? And another one can be, it can start from 7 6 7 1, and nothing else. So another one from 6, so 6 1, but there is no anything else, so nothing from 1. Okay, so are these only these 3? 1 2 7 1 2 1 5 and 7 1. I do not want to look at the answer directly. First of all, let me think more. So how will I, so is this how I do it? So if I do it like this, then I will always start from one number and look at all the numbers. So it will be n times n kind of solution, because for every number I'm looking at all the other numbers, right? For 1 I'm looking at all the numbers, for 2 also I'm looking at all the numbers, 6 also I'm looking at all the numbers after that number. So the time complexity will be too much. 10 1 2 7 6 1 5 10 and 1 2 7 6 1. So how will I, okay, so well, let's think of brute force solution first. Then don't think of optimal. Okay, it's okay if time complexity is too much. Okay, so 10 1 2 7 6 1 5, and I want the combination that is equal to 8. How will I get that? 10 1 2 7 6 1 5, some should be 8. 10 1 2 7 6 1 5, and some should be 8. I'm hungry. Actually, I was about to go eat, but I had energy to make a little video right now, and I was not sure if I will retain that energy after eating. So I just took a chance. When I'm feeling like doing it, I'm doing it. So 10 1 2 7 6 1 5. 10 1 2 7 6 1 5. 1. I'm not speak for some time, I'll just think, okay? 10 1 2 7 6 1 5. Sounds okay. Only 13 minutes left. How am I going to get all the sounds just in one go? Just in one go, I don't think it is possible. Can I just first of all order 1 1 2 5 6 7 and 10? 1 1 2 5 6 7 and 10, right? And then if I order, then it should be easier, because if it is 1, then it can be 1 this, right? So, or actually, rather than descending, I can do ascending, I think. Descending. 7 6 5 5 10 7 6 5 2 1 1. Because if I do this, then I know that okay, this is out of question, and then from 7 I can go from 7 and 8 1, you know. So I know that okay, this is 1, some 7 and 1 and 6 and 5, it's not, it cannot happen. So yeah, if I arrange in descending order, then it becomes easier for me, right, to find that number. So 7 1 and with 6 it will be 6 5 cannot be done, 6 2, okay, 6 7 8, it's already done. So with 6 it is done, with 5 it will be 5 6 7 and 8. So there are 2 ones, so it will be like 5 6 7 5 2 1 2 times, or not? Oh, 6, I forgot about this. 6 2 and then 6 1 1 as well, right? Why is 5 2 1 only occurring one time? Because there are each number in candidates may only be one used once, okay, so that is why this is one solution. It is, I think this is much more easier to draw a tree if I am doing it in descending order. So my solution is, I will start from every number from 10, start from 7, and then start building a tree, start from 6 again, 5 again, so that way. Oh my god, I'm so hungry, I want to go. Okay, so should I code this solution? Is this a recursion or what? So I code this solution. How can I code this solution from 10 to 1 and then 7 to 1? Start from 7 and then look at all the numbers. 6 5 2 1 1 7 and 1 8. Then again start from 6 and 2, and it will be 6 7 8. And if whenever a number reaches like where it is greater, then I will not look at that number, okay? So let's do that then. Order in descending, and then for every number in candidates, just do a recursion function. And also I can say that okay, result will be equal to empty array, right? And do a recursion function which will add and all solution starting from that number, okay? So and my recursion function will be function add starting from number, and it will be I, and so it will look at all of the other numbers and see if it is sum is equal or not. So first of all, the sum will be equal to 7. So for example here 6, and then I'm looking at 6 7 8 2, and 2 is not possible. So so for every number I'm doing that. If I start from 6, then I will do that, right? So 6 5 2 1 1. So I look at 6 5, and okay, 6 5 is 11, so I'll leave it, and I look at 6 2. 6 2 is already 8, so I will do it. And suppose the number was 9, then I would continue doing it. 6 7 8 and 9. So how will I write that recursion function? So 6 7 8 and 9. I forgot how to write recursion function, but let's try to write within 5 minutes. 6 and 6 7 8 9. Sum. It will return a sum. So this will be 1, and it will be like 1 1, and maybe it could also happen like this. 6 2. So if the sum was greater, then it could have been 6 2 6 2 and 1 1, like that. And what if there was another 2 here? Then it would have been 6 1 1 and then 2 again. This is one edge case, right? Because it is like 6 2 1 1 6 2 1 1 in this case. 6 2 1 1, and here also, if I'm going from 6 1 1 to but in that case it would have been 1 1. So if it is 6 2, if it is the same number, then I think that I should skip that. I should skip doing the same number. That way it will just skip duplicates. So there is 6 and there is 2. There is 2 and 1 1. I think I should create a set here so that same number will not be repeated again and again. But no, this cannot happen, because sometimes I might need 6 2 and 2. It's just that I do not want to start from 6 2 again. It is same number. If it is the same number, then if this following number is the same number as previous, then I will not start like this. So that is one point. Okay. Previous, then I should not don't start the array. Okay. 6 2 2. So I should also start the array, and let me think of. I should start it here so that I will see how to form this one. So first of all, I will try to write the recursion function. So my recursion function should look like, if there is an array, then actually I'll write the base case first. So if sum, if it is greater than 8, then I should just return, and if sum is equal to 8, then I should just add result to the result that puts whatever is the running array. Okay, so if sum is equal to 6 7 8, then I'm resulting. If sum is greater than 8, then I'll return. Here also I should return. Okay, if sum is equal to 8, then return. If sum is greater than 8, then return. Otherwise what I should do is I should keep on adding it. adding another number. So if this is the next index, then I think I should add it. So add starting from number I plus 1, this is the next number, and then sum will be equal to sum plus and I can also pass the running sum. So maybe here I can update sum is equal to sum plus candidates I. So here I have updated the new candidate. Okay, and if sum is equal, then I'm pushing. If sum is greater than 8, then I'm not doing it, and then I'm doing it all at starting from sum. Also, actually, I plus 1 and sum, right? Okay, and what I was saying, right? So if candidates I, if it is not equal to candidates I plus 1, then only I'm going to add this. If it is not equal, then only I'm going to call this recursion function. Otherwise there is no point, right? Sum is equal to sum plus candidates. So in the beginning it means that sum should be equal to 0. I comma sum should be I comma 0, right? Because for every candidate sum will be sum plus 1. But how will I come back again? So 6, it will be 6, then 6 and 5, so 5 will return to me. So if 5 will return, then it will be, I should decrease the sum. So suppose I pass 6, okay, and then it will be 5. So sum will be 6 in the beginning, then the sum 5, 6 plus 5, sum will be like greater than 8, so I will return it, and then it will go to 6 again. Yeah, if I return it, then I think and 6, and then 6 and 5 will be done. 5 will return, so it will be the 6, and then 6 and 2 will be there, and if there is 6 and 2, then it will be 6, 7, 8. Six, and then it will be 6, 7, 8. There is 6, then it will be 6, 7, 6, and then 6, 2. It will be 6. It will start from 6, and then it will be start from 6, 6, and then 2. This logic is not so difficult. Start from 6, and then 2, 6, 2, 2, 2, 6. So it should be like this, right? I'm just trying to. So it should be 6 5 first, and then 6 2 6 7 8. So suppose the sum is 9, okay, then it will be 6 7 8 9 10, right? 6 7 8 and 9 10, and then I will jump from 6 to 2, this 2. But since I can jump from 6 to 2 as well, actually. No, it is not required. If it is the same number, then I should not do it. Now I'll jump from 6 to 1. 6 and then 1. From 6, I look at 1. Actually, this like the solution, what is dynamic programming, because what I'm doing is from 6 I'm going to 1, and then from 1 I'm doing that again. Like from 1 also, from this number also, I'm looking at all the other numbers again and again and again. You know, because from 6 I'm going to 1, and then from 1 as well I'm looking at all the other numbers. From 6 I'm going to 1. This is not so difficult, but it is like trying to mess up with my mind. 7 and then 1. I don't know, I should have written something. So I should have looked at this pattern, right? And this pattern is repeating itself all the time. Because from every number I'm going to look at all the other numbers again. If I start from 6, then if I start from 2, then it will be from 2 I look at all the other numbers already. How am I going to code this solution? So start from 6, so there's one below. I have one view, guys, but I'm so sorry, viewer, that I'm not able to solve it properly. Your call is hungry. And it is not just because of my hunger as well, actually. It's also because my brain is not so sharp right now, or it is not never sharp, I don't know, but this is actually not a difficult question. Like, I know what to do, but it's just that the clarity in these steps, it is not coming to me. So many things is coming to my head at once. So should I do it like this, however I'm doing, or should I do like a dynamic programming? Because from, if I go to 2, then I'll, instead of dynamic programming, what I can do is, I think, maybe caching. But if I cache, then from every point, right, I have to, from 2, what is the sum? 3 and 3. So from 2 I have to, from 2 also there is 2, there are so many sums, right? But if I cache, then it will be if I cache, then it will be not so efficient, because when I'm doing like this, then if the sum is not greater than the, if sum is greater than sum, then I'm able to return, right? But if I cast, then I have to look at all the possible sums from that number. So if I cast, I think that casting will work better if I arrange it in a 2 2 5 6 7. If I arrange it like this, right? Because if I arrange it like this, then from 7, what is the number? 10. 10 is 10. I cannot find anything from here. From 7, what is the number? Nothing. From 6, what is the number that will sum 9? Nothing. So sum 6 will return to 0. So this position in dynamic programming, it should return 0. Whatever I cast, this should return 0. And from 5, it should return nothing, because 5 6 they are nothing. And from 2, it should return 2 2 5 6 7. Yeah, it can return from 2, it can return to 5, 2 comma 5. But is it a good idea to cast and save all the possible arrays here? Yeah, I think so, right? Because that way I don't have to go for every number. I do not have to go. I do not have to do these things again and again. Because right now what I was trying to do is, suppose if I'm at 6, and then if I'm at 5, then I'm trying to do 5 2 2 1 again, and then again from 7 also I'm trying to do the same thing again. So for every number, I was looking at every number and trying to find all the possible combinations from every number. From 6 5, I was trying to find the branches from every number. 6 5 2 1 6 5 2 2 and like that. Okay, so that is why I think it is important to cast 2 5 and then 2 5 and then I've already spent so much time, so I'm going to look at the solution for sure, because I do not want to discourage me, because from tomorrow I might think, oh, it will take so long time, so I'll not do it. This will discourage me if I'm taking losses long time. But if I knew that, okay, I'll only spend 21 minutes or half an hour, then I would do it. So just for encouraging me, I will stop after 126. So let's figure out in 1 minute. 2 5 and yeah, 2 5, just 2 5 only. From 2 also it's the same, and from 1 it will be from 1. When I go to 2 5, then I will know that what is the sum right here, so it will be easier for me to get that. From 1 also same thing. So 7 6 5, no, 2 5, yes, maybe 2 and 5, and then oh, it will be 2 and 5 and 2 and 6. 2 and 6 I'll already add it. So 2 and 5 is left. Then from 1 I will look at again. So it will be 1 comma 2 comma 5 from 1. So it will be 1 comma 2 comma 5 and 1 comma 1 comma 6 as well. 1 comma 6 as well. So for 1 comma 6, 1 comma 2 comma 5 and 1 comma 7 comma 6. Okay, let's look at the solution now, because it took such a long time. This is one of the problems in the this is one of the problems in series of combinations. All these problems can be solved with the same backtracking algorithm. backtracking algorithm. That's what I was trying to do, but um, we also listed follow-up problems. So approach is backtracking. So there's just one solution, which is backtracking. So okay, so while backtracking, are we saving a candidate list or not? Are we doing caching or not? That's the thing. In this problem, we need to generate unique combinations with this given sum value. In the worst case, we might need to generate the sum of all combinations in the array. Backtracking can be effectively used. So why did I think of caching then, if we just need to backtrack? Obviously, I think in the first in the beginning I was trying to backtrack, right? So if I was trying to go, I was trying to do that here. I was trying to backtrack. So if I'm going from 7 1, like if I'm going from 6 to 1, then I wanted to come back again from 6 to 2 to 6, and then go look at another number. But I thought that this solution was a bit time complexity increasing, because that way I will have to look at from every number. I'll have to go to all the other numbers, right, for every other number. So that's why I did not like the solution. That's why I wanted to save. Let's see what how this solution is approaching the issue that I faced. In this problem, we need to generate unique combinations. In the worst case, we might need to generate the sum of all the combinations in the array. Backtracking can be effectively used to generate all the possible combinations recursively. Can be effectively used to generate all the possible combinations recursively. Yeah, that's what I'm trying to do here. Like, do a recursion function which will add all the solutions starting from that number. So maybe, so this is a backtracking solution only. Starting from that number, I was trying to add all the other solutions. But I just wanted to have more efficient solution which included caching, I guess. Okay, so please do a brute force solution, as in just thinking of optimal solution again and again. Okay, so, and also please be clear of the issue that you had in mind. So was I clear of the issue that I had in mind? I think yes, right? The issue I had was from 6 I had to go to 5, and then from 5 I had to go to 2 again. And then I think instead of for every number of candidates, maybe I could have done it just from 10, just while recursion only, you know. So from 10, if I go to 7, then from 7 I have to go to 6, from 6. So only while recursion I could have returned the sum. I think, yeah. From 7 if I go to 6. Okay, let's look at the solution. I'm hungry. Backtracking can be effectively used to generate all the possible combinations recursively, but I think the confusion and the issue that I had in my mind, I think this is actually good to have, because I'm starting from fresh, this LeetCode thing, and today I should think about it more, you know, the issue that I came up with. Okay, because if I know the solution, then next time it will just be a guess. The solution will come to me even without thinking. So I think I should spend more time on the issue that is coming to me right now, because I'm sure that it will not come to me next time when I learn the solution. But anyway, I do not have time, so let's look at it. Backtracking can be effectively used to generate all the possible combinations recursively. Backtracking incrementally builds candidates to the solutions and abandons a candidate as soon as it determines the candidate cannot lead to a final solution. Yeah, that's what I wanted to do. For example, in the given problem, we can discard the when it exits the, yeah, that's what I wanted to do. Using backtracking, we incrementally build the solved combinations. When we find the current combination is not valid, we backtrack and try another option. For the first option, we add the current element to the current combination array and move this the combination to the next index. Similarly for the second option, we remove the element from the combination and move this combination to the next index. Therefore, for every index, we explore two possibilities of including and excluding that value and calculate the combination sum of the maintained. If the desired sum is reached, we can append the list to the answer list to demonstrate the. Okay, well, is it this simple? Did I think too much? So candidates is 1, 2, 3 and 3, right? So first of all, I'll start from nothing and then include 1 and include 1, 2, exclude, include 2 and exclude 2, include 2, 3. Since we need to return unique combinations, we can group equal values of the array together. The simplest way to group all the elements is by sorting them. Now suppose the frequency of element is frequency and you need to make backtracking calls for all its possible frequencies between 0 and frequency, then we can simply pick them from the beginning of its group in the sorted array. We need to make backtracking calls for all its possible frequencies. Initialize an array of its lists to store the combinations. Sort the candidates in non-decreasing order. Return list. Okay. Then time complexity is O and to the power n, because in our worst case our algorithm will adjust all possible combinations from the input array. Again, in the worst case, let's assume that each number is unique. The number of combinations of an array of size n would be 2 to the power n, right? And each number is included and excluded. Okay, actually this is a good trick. Space complexity is O of n. But I still do not understand this one. So what will I do here? Like 1, 2, 3, 4. Okay, so here what should I do? So if I start with nothing, then it will be 1 and then nothing, and then include and exclude. So I think this is where I was missing. Okay, this is what I could not do properly. So because I was trying to add all the numbers every time, but this is a good pattern actually, because from 1 I can go to 2, and then I do not want to include 2 here. Okay, so from 2 I want to include 5, and then here I do not want to include 5 at all. So from 5 I here, and then there is another number, right? 6. So from 6 I will include 6 here, and here I will not include 6 at all. From here I will include 7, and here I will not include 7 at all. Here I will include 10, I will not include anything. So yeah, this is not even a backtracking. I mean, backtracking would be like this, right? 6 and then 2. This is a different kind of problem, different kind of solution, but this is a good pattern. If I had come up with this pattern, then it would have been great. But yeah, so this is a way. Just include ones and not include ones. This is a good solution that I can memorize or what. But anyway, so if I do this, then yeah, the solution will come in just one recursion. But anyway, time complexity will be to the power n, because we are dividing into 2 branches for every number, so it will be to the power n. But still, the solution I like it. So there is 1, and then so suppose if there is just 1, 2, 3, 4, 5, then there will be every possible combinations, right? So it will be 1, 2, and next time I will not include 1, so it will just start from 2, and then another one will be 1, 2, 3, another one will be just 1, 2, and then I will include 4, and then here I will not even include. Here I will include 4, and I will not even include 4. So this is a really great strategy of including one number and not including that number next time. Okay, so this solution actually needed this pattern. I needed to know this. Since I did not know this, I struggled to find a solution perfectly, because this kind of solution, it was not so feasible, because I had to look at all the numbers again and again from 6 then 2, so here my solution was like, it was like 5 4 3 2 1, and then I had to look at from 5, and then 4 4 3 2 1 again, and then again from 4 I have to look at all the solutions again. So instead of that, right, instead of looking at all the numbers, I could just create a tree, and since 1 will not include anything, so it will be 1. Actually, I think my solution and the solution is similar, because this will not include anything, and from 4 this will not include, this will not even include 4. Okay, and here it will include 3, but it will not even include 3, and then it will include 2. So it is like, if I start from this root, it is like I'm starting from 4. It is like I'm starting from 4. It's like I'm starting from 3. It's like I'm starting from 2. But from 5, and then 4 3 2 1, right, and then from 3 I'll again do either I'll do 2 or I'll not do 2. So from 5 I'm looking at 4 going to 4. This is not even 4. So it will be like 5 and nothing, and 4 and nothing, and here also 4 and nothing. So for every branch I'm doing 4 and nothing. Actually this solution is same as my solution. It's just that the coding will be easier if I do 4 and nothing, 5 and nothing, like that. It is exactly equal same as my solution that I thought in the beginning, because look at here, because at every point I'm looking at all the possible combinations. Like for from 5 I'm looking at 4, and then from 4 I'm looking at all the possible combinations, and then from 3 also I'm doing all the possible combinations after 3. From 2 also I'm looking at all the possible combinations after 2. So yeah. So the concept is same, but the coding process, it is different, because I need to include one time and not another time. See, if candidates I is equal to, then continue. That's what I did right here. If it is not equal, then only do it. No, otherwise don't do it. I think concept wise I was good, but I think I need to learn how to code this properly, because that's what I missed here. I plus 1 and then sum, then I could not remove it. I was thinking about how will I actually, so I should have completed this solution, Instead of completing this, I thought about saving it into cache, but I should have completed the solution. I think that it would have looked like this. It would have looked similar. Candidates I is not equal to candidates I plus 1, then add starting from number. Then I think what I do is Okay, I'm too tired. I will go now. So do the solution again. So this problem again though. I'm too hungry right now, so I will go and eat something. But anyway, I knew this, right? That how to do it. I do not even want to learn the solution because I do not want to like hamper my creativity. Because if I learn the solution, then next time that solution will come to me. I learn the pattern, and I do not want to learn the pattern. Uh, so what I will do is I will do this question next time again, because I know a little hint, right, that I can do left and right, left and right, left and right. So I'll just take this as a hint and then continue from my own argument. Okay. Okay, so I'll